Welcome to another GCBASIC tutorial for the 16F175 chip family. We're going to read the ADC, which is the analog to digital converter. So, this is the new set of tutorials. This is part 3, and we're just advancing through the capabilities. So, I'm in this for the points, for the like and subscribes. Like it, thumbs up, please, and subscribe. That's what I'm here for. Thank you. So we are part of a 20 set of videos. We got the LEDs flashing in the previous tutorial. Now we're going to actually use those same LEDs to represent the value of the analog to digital converter, or ADC. So I'm not going to show you or any justification of what GCBASIC is. Pretty cool, works really simply. But what we're going to do is just go straight into it and say, what are we doing? So we're going to configure the ADC. We're going to run a conversion, so that means read the value of an external potentiometer. Then we're going to put that into a variable, and we're going to display the results on a set of LEDs. Very simple. But in actual fact, we're going to introduce some great concepts. So what we're going to do is we're going to hook it up to the ADC on RA0, which is pin 2, and we've got a little diagram here, and I've taken this from, I'm not sure where I've taken it from. I've used it many, many times. But essentially, this is RA0, which is the same as the one here on the top left-hand corner, the ADC. It's connected through a little resistor and a little capacitor. And as I rotate this potentiometer, the 10K potentiometer, I will get a value between 0 and 255, representing the value of the ADC. And I'm going to put that on the LEDs. So what we're going to do, GCBASIC will complete the initialization for you relatively simply. It's a simple one command. We're going to put the return value into a variable. We're going to read the ADC. We're going to take the value of 0 to 255, and we're going to set the LEDs, and we will do it all over again and again and again. This is the flow diagram. So we're going to initialize the chip. Bring my pen up. Initialize the chip by a simple command. We will create a variable. I'll show you how to do that. Then we're going to read the ADC and assign it to our variable that we previously created. And then if the value is between 0 and 250, there'll be no LED set. If it's between 50 and 100, set one LED. 100 to 150, set two LEDs. 150 to 200, set three LEDs. And finally, four LEDs. And then do the whole thing again. I think there's a little delay in there. Can't remember. We'll see. But it's a very simple process. So some prerequisites here. I've assumed you've installed the software. You've got your program running. You've got the new chip attached, and you've got four LEDs. And now you've got a potentiometer connected. So what does mine look like? It looks like this. I've got it attached to pointer. A0 and C0 to 3. One of those. Oh, that's annoying. That's just me clicking on the screen improperly. These have all got LEDs connected via suitable resistors. So let's have a look at my camera before we go off to do that. This is what I've got. We left it yesterday. We have four LEDs sitting here, one blue, green, yellow, and red, and they're connected by these flying leads into this chip here. And this could be your own board. It doesn't have to be this green one. Just put the chip inside of a prototype board and build your own. And then what I've added, I've got a little potentiometer here in blue, and I've got that flying lead connected over to my A0. That's it. That's all I've done. No difference. And so when I program it, magic's going to happen, hopefully. So read the ADC, uses a byte, for very simple logic. Let's go into and get that started. So if I press the Windows key, GCStudio. It's the first thing that comes up, and I'm just going to select that, and it will take me into the GCStudio menu. There we go. Into my desktop, zoom in a little bit. Oh, let's zoom in a bit so we can see it. And I'm going to take the chip range demonstrations that we've been working on previously, and when I hover over it, it will give me the folder, and that is the demonstrations, vendor boards, GCBASIC boards, or Great Car Basic demo boards, and this particular range of chips. And there's others up there, so I can select that, and it will take us back to where we left. Oh no, it hasn't. It's taken us to the file we're going to be working on. So let me just show you how you can get in there. This IDE, this is the IDE. If I press Control B or take this up the top here, that says Control Shift E. Control Shift and E does the same thing. Interesting. So does Control B. I'll use Control B because it's quicker. Right, I am going to use this demonstration called 050 show A to D value on LEDs.gcb. Shut that Explorer window down by pressing Control B. And all the green stuff is for your own delight, and it's the documentation. Let me just get rid of that. The first thing we've got in here is, as before, the chip, hash chip, and then the specification for this particular chip. And hash option explicit means that you need to declare all your variables. We're going to do that. The little diagram we saw in the PowerPoint as an aid memoir, so when I come back to this in years' time, I can go, oh, how was it all hooked up? Bit of documentation. We saw all these things here before. I've declared a port called LED port, let's see, and then I created a constant called potentiometer on RA0. I did that. It's a new one. I don't know if I even use it. We'll see. I've set the LEDs as DIR, then the port as an output port, and then I've set this new potentiometer as an input. Now, the only reason I put potentiometer as a constant and set it as an input so that you can see it, they're not actually needed, but they're there because then you will not forget you have a potentiometer connected to RA0. They are purely there for documentation purposes only. So what we've done, we set up some constants to the LEDs, and we set them as outputs. Now into this program. How do we declare a variable? And that is a variable that's in random access memory. We use DIM or DIM. And the one I've created is called ADC val. GCBASIC is not case sensitive, but that's the format I use, ADC val, so I can see it as a byte, and that means it will store a value between 0 and 255. There are other types of variables that we can use, and we'll see those as we go through these tutorials. Well, I've got a do loop. We've seen a do loop before, so anything between this do loop and the bottom, there's another loop down there. Oh, let me just take out that green stuff. It's in the loop. It says do loop. If I just minimize this code, there we go, do loop, and it's going to do stuff constantly between there. And what's it going to do? It's going to assign something into my variable called ADC val. And how do we do that? Read AD. And this will do a read analog to digital. And this is the port name. And the port name is actually documented. And I'll show you where that's documented shortly. And it's a particular name. It's a chip-specific constant. ANA 0. ANA 0. I think this one has, I don't know, it might have 22. I'm not quite sure. But we can have a look. Let's figure out how we know what that name is, because we have a utility that we can use to look up these types of names and other constants. Let's go into there now. Function key F4 to bring up a list of the tools that are installed. PIC is what I've typed, and it's got PIC info. If I go into PIC info, it brings me up a dialog. I'm going to zoom in on the desktop so you can see it clearly a bit more. Let me just see if I can get it as big as possible. I am going to do it like this to start with, and then we will do it. I'll zoom out slightly. Here is my chip, and if I drop on this drop down, there are all the chips supported by GCBASIC. So if I select one, it changes the screen, it updates the information, but what I've got, if I just zoom out slightly, I can type in my chip name at the bottom in this search window, 16F17556. That is the one that I am working on. I can look at the chip data. I can look at some options, some registers, some bits and interrupts, which we will come on to during these tutorials. Let's look at the chip data, and it says here, ADC constants, and they're called ANA. AN, that's fixed. They might be A to G, 0 to 7, and it says here usage AN0 ... to ANG7. That tells you you've got ANA through to .7 and ANB, ANC, AND, exactly. So these constants are available. So it gives you an example, ANA0. So you don't have to go look in the data sheet, the same names, but there's a little tool here. So we're talking to ANA0, which is attached to the port AN, RA0. Now, what we then do is we'd have a thing called a select case. So it says, well, whatever this value is, ADC, select case of ADC, we can say, well, if it's the case of 0 to 49, set no LEDs. The case of 50 to 99, set 1 LED. The next case, set 2 LEDs. The next case, set 3 LEDs. And finally, else, set 4 LEDs. Then wait for 100 milliseconds. Well, to be honest, that's pretty simple to do. So what we can do is program this into our microcontroller, shall we? Let's go out to the camera as well. There we go, there's the camera. And I'm going to press function key F5. I could take this little icon at the top, which says make hex and flash, or I can take the menu from function key F4. But I'm going to press F5. It's compiling it up. It's taken the parameters that are required from the static libraries, and it's programmed it. Now, we have no LEDs. Why is that? Because this is my little stickler. I'm going to rotate my potentiometer, and as I rotate the potentiometer, I get different LED states. One, and trust me, if I turn it fully to the anti-clockwise, I'm bringing it clockwise, I get 1 LED, 2 LEDs, 3 LEDs, 4 LEDs, and now I'm fully on and off. Very little to do. Now, in the example code I've given you as a part of the tutorial, another way of doing things. So in here, we've used select case. If I just minimize that, and I've written here another way. And another way of doing it, you can just hard code it yourself. You can say if something, if this, if that, else if. Lots of different ways of skinning this, making this work. Skinning the cat, we say in English, doing it. But what we've done, we've read from the ADC in this microcontroller, and we're processing the value of that, and we're putting it onto 4 LEDs. Later on in the tutorials, we'll see that information being placed on a serial terminal, but that's for later. So what have we learned? Back to the PowerPoint. We've learned that we can read the ADCs to set the LEDs. We've used a byte variable, our first variable, and we've used some simple logic to display, and we're really testing the return value and setting these LEDs extremely simply. Back to the desktop. So what we're going to do is we're actually, in the next tutorial, we're going to sequence the LEDs. using a delay that's a result of reading the ADC. But we're going to use a different type of command to get our value because we're going to get a much bigger number. We want to use that big number, and then we'll use that to actually delay the rotation that we saw on a previous demonstration so that we can work through different commands and different capabilities. And with that, enjoy.